Concrete is produced by mixing cement, fine aggregate, usually sand, coarse aggregate, and potable water. Sometimes we add admixtures in concrete to get the desirable properties in concrete. The strength of concrete depends on the properties of ingredients. By adjusting the proportions of the ingredients, concrete of different strength can be prepared. It is therefore necessary to study the properties of ingredients that make concrete. In this session, we will discuss briefly on cement. Cement is a material with adhesive and cohesive properties. Cement, when mixed with mineral fragments and water, binds the particle into a compact whole. There is an exothermic reaction between cement and water to form hydraulic products in form of viscous cement paste, which coats the aggregate surfaces and fill some of the void spaces between the aggregate pieces. This cement paste loses consistency on account of gradual loss of free water through adsorption and evaporation and subsequently sets, transforming the mixture into a solid mass. Can you see this defect which is present in the concrete? You can see that there is hollow space and cavities left in concrete mass on surface. Now this kind of defect can be inside the concrete mass too, where concrete could not reach. This kind of defect is called honeycomb. So the question comes, how is this kind of defect is associated with cement paste? Well, if the consistency of cement paste is either excessively harsh or excessively wet, the aggregate tends to separate out of the mix, that is segregation, which may result in a honeycomb appearance on the hardened concrete. Present-day concrete is made of Portland cement, which is made by burning together an intimate mixture of limestone with alumina, silica, and iron oxide bearing materials like clay at temperature of about 1400 degrees centigrade. The resulting clinker obtained is cooled and grinded into a fine powder after mixing with 3 to 5% gypsum. The question is why gypsum is added while grinding of cement clinker. As soon as the water is added to cement, the reaction between cement and water immediately starts, leading to flash setting. This is not acceptable since mixing of the ingredients and placing of concrete at required location requires some time. Addition of gypsum retards and controls the setting times after adding water to cement. This ensures that concrete will not set too quickly before it is placed and compacted at required places. Let us now continue with Portland cement. This cement contains four major compounds: tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminoferrite. As per cement chemist notation, lime or calcium oxide, that is CaO, is represented as C, silica or silicon dioxide is represented as S, alumina or aluminum oxide is represented as A, iron oxide is represented as F. So your tricalcium silicate can be given as C3S, dicalcium silicate C2S, tricalcium aluminate C3A, tetracalcium aluminoferrite C4AF. By altering relative proportions of these major compounds, that is C3S, C2S, C4AF and C3A, and including appropriate additives. Different type of Portland cement with different properties can be made. Adjusting fineness of cement can also control the properties of cement. Let us have a look into types of cement which IS 456-2000 permits. So we have 33, 43 and 53 grade ordinary Portland cement OPC. This cement is most commonly used in general concrete construction where there is no special durability requirement. The number 33, 43 and 53 corresponds to the 28-day characteristic compressive strength of cement as obtained from standard tests on cement sand mortar specimens. Next is rapid hardening Portland cement conforming to IS 8041 RHPC. It is similar to ordinary Portland cement except that it has more C3S and less C2S, and it is ground more finely. It is used in situations where a rapid development of strength is desired. The next is Portland slag cement PSC. PSC is made by intergrinding Portland cement clinker and granulated blast furnace slag, which is a waste product in the manufacture of pig iron. It has fairly high sulfate resistance, rendering it suitable for use in environments exposed to sulfates in the soil or in groundwater. Portland pozzolan cement. So we can have two types. One is fly ash based and another is calcined clay based. These both materials are pozzolan, that is a mineral admixture containing silica, and is added to Portland cement to get Portland pozzolan cement. These cements hydrate and gain strength relatively slow and therefore requires curing over a comparatively longer period. They are suitable in situations where a low rate of heat of hydration is desired. Next is hydrophobic Portland cement HPC. This cement is obtained by intergrinding Portland cement with 0.1 to 0.4% of oleic acid and stearic acid. The hydrophobic property is due to the formation of a water repellent film around each particle of cement. During the mixing of concrete, this film is broken, thereby making it possible for normal hydration to take place, although its early strength is low. This cement is suitable in situations where cement bags are stored for a prolonged period under unfavorable conditions because it deteriorates very little. Next is low heat Portland cement. It is a Portland cement with lower contents of the more rapidly hydrating compound C3S and C3A. The process of hydration is slow and the consequent rate of heat generation is also low. This is desirable in mass concreting of gravity dam, as otherwise the excess heat of hydration can result in serious cracking. However, because of the slower rate of strength gain, adequate precaution should be taken in their use, such as with regard to removal of form work. Sulfate resisting Portland cement. This cement is obtained from Portland cement with a very low C3A content and ground finer than OPC. This cement is sulfate resistant because the disintegration of concrete caused by the reaction of C3A in hardened cement paste with an external sulfate salt that can be present in soil or water is inhibited. Storage of cement. Cement is very finely ground and readily absorb moisture, hence care should be taken to ensure that the cement bags are not in contact with moisture. They should be stored in airtight and watertight sheds and used in such a way that the bags that come in first are the first to go out. Cement stored for a long time tends to lose its strength. Loss of strength ranges from 5 to 10% in 3 months to 30 to 40% in 1 year. It is better to use the cement within 90 days of its production. In case it is used at a later date, it should be tested before its use. Here is the Ambuja cement bag. Can you see ISI mark on the bag? This denotes that the cement is as per the specification laid by Indian Standard Code. Can you tell which type of cement it is? Remember when we discussed type of cement which IS 456-2000 permits? There we can get our answer. The cement is Portland Pozzolana cement. However, without looking into code, in cement bag, the cement type is mentioned as can be seen. It is best to use cement within 90 days of its manufacture. Let me tell you to identify the date of manufacture of cement. Here we have Ultratech cement. Remember, D is date, W is week, M is month, Y is year. So the manufacturing date from above is 20 June 2019. You can easily find that this day comes in week number 25 in the year 2019. Let us take few more examples. Here we have ACC F2R Superfast Cement. This is a composite type cement prepared by adding slag and fly ash in Portland cement. 24 indicates date, 4 indicates week, 1 indicates month, 20 indicates year, 25 and 22 is the percentage of slag and fly ash in Portland cement. The manufacturing date of cement is 24 January 2020. We'll consider a last example now with Imami Double Bull Pro Sem Cement. This is a PPC cement. Here we have week 39, month 9, year 2018, and fly ash added is 34%. The date has not been mentioned. So the manufacturing date, if you check on 39th week of 2018, we can make it out that cement manufacturing was between 24 September 2018 to 30th September 2018.
To identify the usage of cement for different purposes based on its durability and performance, quality tests on cement are carried out. Tests that are conducted on this cement in the laboratory are fineness test, consistency test, setting time test, strength test, soundness test, and chemical composition test. Let us now discuss very briefly on each of these tests. Fineness test. The fineness of cement is responsible for the rate of hydration, rate of evolution of heat, and the rate of gain of strength. Finer the grains, more is the surface area and faster the development of strength. The fineness of cement can be determined by sieve test or air permeability test. Here you can see a 90 micron sieve that is used to conduct the sieve test. Here you have Blaine's air permeability test apparatus to compute the specific surface area of the cement. Consistency test. Now this is a prerequisite test to find the setting time of cement. Now what is consistency? Consistency is minimum quantity of water required to initiate the chemical reaction between water and cement to form a paste. Standard consistency is determined using Vickett's apparatus. Now, what do you mean by standard consistency? Standard consistency of cement paste is defined as the water content which will permit a wicket plunger, so this is a plunger, of 10 mm diameter and 50 mm length to penetrate depth of 33 to 35 mm within 3 to 5 minutes of mixing. Next is setting time of cement. Wickets apparatus is used to find the setting time of cement, that is initial setting time and final setting time. Initial and final setting time measures the rate of solidification of standard cement paste. Initial setting time indicates the time when the paste becomes unworkable, whereas final setting time is the time to reach a state of complete solidification. Strength test. The strength of cement cannot be defined directly on the cement. Instead, the strength of the cement is indirectly defined on the cement mortar of 1:3. The strength is measured in terms of the stress at failure of hardened cement mortar specimens subjected to compression and tension test. So here you can see this is the hardened cement mortar specimen, which is a cube, and here you have this hardened specimen made from a briquette mold to conduct the tension test. Soundness test of cement. What is soundness? Soundness is a quality that indicates that the cement paste, once it has set, does not undergo an appreciable change in volume. If your cement is unsound, it can lead the concrete to crack. Now, why cement becomes unsound? It is becoming unsound because of uncombined lime and magnesia in cement. Volume expansion may be due to uncombined lime and magnesia in cement. This test is conducted in Le Chatelier's apparatus. Now here in the background you can see you have a Le Chatelier's apparatus. In this test, composition of various oxides present in the cement are analyzed to ensure that impurities are within the prescribed limits. Before mixing the cement at construction sites, some quick tests can be conducted on the field. Now, it can be on color. The color of the cement should not be uneven. It should be a uniform gray color with a light greenish shade. Presence of lumps. The cement should not contain any hard lumps. These lumps are formed by the absorption of moisture content from the atmosphere. The cement bags with lumps should be avoided in the construction. Cement adulteration. The cement should be smooth if you rub it between fingers. If not, then it is because of adulteration. Float test. The particles of cement should flow freely in water for some time before it sinks. Date of manufacturing. It is very important to check the manufacturing date because the strength of cement decreases with time. It is better to use cement before 3 months from the date of manufacturing. Thank you.